Again, we're minimizing this expression. The derivative with respect to b of our total squared deviation is what? Well, let's just take the derivative with respect to b of the first term. All the other terms are going to have similar form, and we're going to be able to do something very similar to what we did with the derivative with respect to a. So let's see, the derivative with respect to b of y1 hat minus a x1 minus b quantity squared is what? First of all, it's the derivative with respect to b of our inner function, which is y1 hat minus a x1 minus b, multiplied by 2 times our expression, which is 2 times y1 hat minus ax1 minus b. This expression turns out to be a little simpler than it was before, because in this expression, the derivative with respect to b is simply -1. y1 hat is a constant number, x1 is a number we've observed, and a, being the other variable, is treated as a constant. So that what we have is just -2 times y1 hat minus ax1 minus b. So that the derivative with respect to b of the total squared deviation is going to be what? From each term here, we're going to have a -2 y1 or y2 or y3 hat. So this is going to be, first of all, -2 times y1 hat plus y2 hat plus, and so forth. Add up all our y hats. And then we're going to have +2 times a times x1 plus x2, and so forth. Add up all our x values. And then it's going to be what? It's going to be minus 2b, and we're going to have one of these for every data point. So that's going to be times 1 plus 1 plus, and so forth. All these ones, that we're going to have a 1 for every data point. For every one of these terms, we're going to have a 1 in this factorization. So that this is just going to be -2b times n, where n is the number of data points. Now I'm going to take the liberty to write this out in summation notation. This is -2 times what you get when you add up all your y's. That's -2 then times the sum of your y hat values. Now I'm going to call those y sub I, where I is the index. It runs from 1 to whatever your number of data points is. If you got 100,000 data points, it'll run from 1 to 100,000. If you've got 100,000 data points, I hope you have a good machine. Well, any machine will do that. You're going to use a computer when you got a lot of data points. In any case, we see that that's -2 times the sum of all your y values, and then it's going to be plus 2a times the sum of all your x values. Now these are your y hat values. That's a sum of all your observed y values. This is the sum of all your observed x values. And then this is -2b times n, where n is the number of data points that you've observed. And we can make this a little more complete by saying this is the sum from I equals 1 to n. This is the sum from I equals 1 to n. Now if we write this without the I equals 1 and n, it's simply understood that that's what we're summing over. But then this is our expression for the derivative with respect to b. In terms of our summation notation, we can write the condition on a as 2a times the sum of the xi squareds minus 2 times the sum of the xi yi hat squared numbers, and these are just data numbers, plus 2b times the sum of our xi's equals 0. Our previous expression for the derivative with respect to b, which also has to equal 0. Get these lined up a little better. Okay, not sure we can see it, and of course we've managed to lose our focus. Let's see if we get that back. Okay. The b derivative of our total squared deviation also has to be 0, and that gave us this expression, so that we know that in addition to this equation, let's see if we can keep our focus here, we have negative 2 times the sum of the yi hats plus 2a times the sum of the xi's minus 2bn equals 0. All that remains is to solve these two simultaneous equations for a and b. Everything except the a and b is a number that we presumably have observed. All the xi's and yi hats are just numbers that we know. In order to solve these equations, which can look a little bit intimidating, it's really not that bad. We have only a single b term in this equation. Remember that one method of solving equations for two equations for two variables is solve one equation for one of the variables in terms of the other and plug that into the other equation. Might look a little messy, but it's going to turn out not to be too bad. So what do we have? From the second equation, I'm not sure what that is supposed to be, but I'm going to make it an implication sign. Second equation gives us solution b equals what? In order to solve for b, all we do is add this and subtract this on both sides, and then divide by negative 2b. That's negative 2n. And that's going to be fairly easy if we just keep our signs straight. We're going to end up with, I believe, 2a times the sum of our xi's minus 2 times the sum of our yi's, all divided by 2b, so that b is, the 2's all divide out, nothing but, and it's not 2b, it's 2n. Let me fix that. Okay, I've made the repair that b should have been an n. Anyhow, we have a times the sum of xi minus the sum of yi divided by n. We plug this expression back in here, and we can solve for a. Now, to save a little bit of writing and a little bit of mess, I'm going to go ahead and solve this for a in terms of b, and then we'll plug our expression for b into this. And we get, the only expression here that has a is this one, so we're going to add these to both sides. The 2's can all be divided out, and we're going to end up with a equals sum of xi yi hat. And let's stop there for just a second. I wrote down a yi hat squared here. That does not follow from any of the previous expressions, all of which were accurate. Writing down so many 2's, I just let my hand get carried away here, and I wasn't necessarily thinking clearly about what I was doing. Okay, so anyhow, we're going to have a xi yi hat sum. And then we're going to have 2b times the sum of the xi's, and that's negative. Let's fix that. Okay, I've made the repair. And that's then going to be divided by our sum of xi squared. Now, b itself is this expression. If I plug this expression in here, and I'm not going to point out every detail of the process, I find that A ends up being equal to the sum of the xi yi hats minus, okay, it's going to be 2 times this times the sum of xi. Now, and I've got another mistake. Let's fix it. That's not a 2. All the 2's have divided out here. Okay, we've resolved the question of 2b or not 2b. Now we have then minus b times the sum of the xi's multiplied by this term. I'm sorry, we have b, which is this term, multiplied by the sum of the xi's, and that gives us sum of xi times each of these, all divided by n. My strategy for solving for a and substituting was not particularly good, because what we're substituting is going to contain an a, but we're just going to deal with that. And let's get the right color of marker here. Okay, so we have a sum of xi multiplied through this expression, and that's going to give us minus what? A times the sum of xi times the sum of xi, which is sum of xi quantity squared, minus the sum of the xi's multiplied by the sum of the yi's, all divided by n, all divided by the sum of the xi squareds. Now, this clip is already running too long, so we're going to go to another clip and finish this up. Not particularly difficult, as you'll see.